This assignment will be looking at advanced Lewis dot structures. We're going to start with number 1, the puzzle of oxygen gas. Oxygen gas exists as a diatomic, which means there are 2 of them, O2. That means that those 2 oxygens are bound together in a covalent bond. So let's try and figure that out. First thing that we need to do to draw this in the Lewis dot structure is to figure out how many valence electrons that oxygen has. Oxygen is in the 6th column, meaning that it has 6 valence electrons around it. So I'm going to draw my oxygen. With its 6. So go ahead, take a few minutes, see if you can draw the resulting molecule that would be formed from O2. So what you may have noticed is this is not as straightforward as our other Lewis dot structures have been. If you try and combine this like we had before, the problem will be like this. If we put our oxygens together like so, both of our oxygens are not fulfilling their octet, meaning they both don't have 8 electrons surrounding them. At this current juncture, both of the oxygens have 7, and that's a problem. We could try and do it on the other side the same way. I rotate it, I put it in here, but we end up with the same problem. Both of our oxygens are missing an electron that they need. So, what can we do? So I'm going to draw them together like this. Instead of adding more oxygens, which you may be inclined to do, but you shouldn't because it's telling you that it's just O2, so you can't add more. What you can do is move the electrons into the existing bond between them, and we'll end up with what's known as a double bond. So this equates to this. It has a double bond. And that is the solution to this puzzle. There is one other way of doing it that I want to show you. It's called the diagonal method. In this method, we pull the 2 together like so, and we end up with our double bond. So that is the diagonal method, but best to use the method I'm going to show you in number 2. So the solution here, double bonds. Oftentimes you will need double bonds and sometimes triple bonds to make the structure complete and work. So the goal of any molecular structure is always to fulfill the octet. So here we have fulfilled the octet, in which our oxygen has 8 and this oxygen also has 8, so our oxygens are complete. So let's look at this eraser method. So we're going to make double bonds using the eraser method for the molecular formula C2H4. The first thing to do is to make all the single bonds. So we're going to start with carbon. And I'm going to put the 4 electrons it has around it. And then I'm going to add a second carbon because there's 2. Bind it to my first carbon. Again, leaving space because it only has 4 valence electrons if we look at our periodic table. And then we add our hydrogens, which each only have 1 electron in its valence, and there are 4 of them, so I'm going to add 4. And I'm going to make them even. I'm going to put 2 on each. Make them symmetrical, like so. So again, we encountered the same problem that we had above. Each carbon is missing 1 electron that it needs. But if each carbon is missing 1 electron that it needs, then they can share those 2 electrons and both of the carbons will have their octets fulfilled. So the second part is to erase the single dots and make a double bond. And we're going to erase the single bonds and move the erased dots into a double bond. So we're going to erase this one and this one. And I'm going to put the new ones in black. And I'm going to move them into a double bond. And now all the octets are full. Each carbon has 8, each hydrogen has 2, and everything is good now. So we're going to make the line structure out of this. Start with our double bond, carbon. And then I'm going to space the hydrogens out evenly. So one going down and down, another one going up. And then we're going to put our hydrogens on, so we'll just kind of put them in the same way that I had them oriented above. Got our hydrogen and our hydrogen. So we've got a double bond in between our carbons and single bonds for our hydrogens, and that is how we solve this problem as well.